Hello. Today, for African Liberation Day, we are going to learn about energy. There are two main types of energy: potential energy and kinetic energy. Potential energy is energy that is stored, and kinetic energy is energy that's in motion. Those are the two main types of energy that there are. But there are also different forms of energy. There's two forms of energy that we're going to work with today. That's chemical energy and elastic energy. There's thermal energy, there's nuclear energy. We're not going to deal with those today, but you should know that there are at least 10 different forms of energy that we can use in all types of ways in our lives. But today, for African Liberation Day, and what we're going to learn, we're going to look at chemical energy. And so, first, when we look at chemical energy, we can get chemical energy from batteries. Now, a battery has electrons in it that flow, and then we can actually create electricity. And what gives us electricity? What types of things give off electricity in our homes? Light bulbs. So we'll have a wire, a battery, and you don't have to have this holder. You can just have, this is a D-cell battery that you can get from your local store, discount store. A small battery that you can get from a hardware store. And these wires have clips on the end, but you don't have to have wires that have clips on the end. And I'm going to use this holder here to screw the battery in, but you don't even have to have that. And so when we connect wires together, now I'm going to put this back in the holder just because it's a little easier for me to show you what we're doing. So what we have to have is a connection between both ends of the battery. And you'll notice on a battery there's a positive end and a negative end. All right, those are the poles of the battery. And so once we connect, we get electricity. And this flow of energy from the battery through the wires is what we call a circuit. Circuit, C-I-R-C-U-I-T. It's sort of like the word circle. Electricity is a form of chemical energy. We can use a simple battery with two wires connected to a bulb in order to light the bulb. If we want to slow the flow of energy from the wires to the bulb, we use something called a resistor. The root word is resist. And a resistor in the real world is someone who resists something that they feel is not right. But in electricity, it has the same function. It's something that resists. It is what we call resistance. So chemical energy is one form of energy, and the next type of energy or form of energy that we're going to work with is elastic energy. And we can use rubber bands to show elastic energy, or springs. Have elastic energy, or slingshots. Another example of elastic energy. or a bow and an arrow. All of these are examples of elastic energy. Young pioneers science experiment that we're going to do today, we are going to do the rubber band test, and these are the things that you're going to need in order to do the rubber band test. First, you're going to need a ruler that has both the metric system and inches on it. So the metric system is going to have centimeters, so you're going to make sure that you have a ruler with the metric system on it. You also are going to have some rubber bands. Make sure that you're using the same size rubber band for every trial that you use. So rubber band, you're going to use masking tape in order to mark where your feet are going to start your launch from. If you go outside, you can do this outside, and you can use sidewalk chalk. We're indoors in a large space, so we're gonna mark where our toes will be using masking tape. And then you'll need a tape measure, because once you launch the rubber bands, you're gonna have to measure the distance that the rubber band traveled. You're going to put the rubber band on the edge of the ruler. You're going to hold the ruler at the same level each launch. You're going to put it at the distance that you're going to launch it from, and then you're going to release the rubber band. Now that we've set up our data chart and we know how to launch the rubber band, you're going to mark your space where your toes are at. You're going to stand and you're going to do your launch. You're going to need a helper to mark where the rubber band lands. So now Tori's going to demonstrate launching, and I'm going to be her helper. Okay, this is trial 1 of distance 15 centimeters. This is trial 2. This is trial 3. Now that we've launched our rubber bands 3 times, we're going to measure the distance that it traveled. If your tape measure or your distance is longer than the tape measure, you're just going to mark it and then continue to measure.
Now we are finding the average of distance 10 centimeters. So you add up all your numbers together and then divide by 4 to get your average for each distance. And it's okay to use a calculator. So 232 plus 252 plus 258 plus 268 equals 1002. Now you divide by 4 and you get 250.5. Now I'm going to do that for distance 15 centimeters. 332 plus 300 plus 315 plus 321 equals 1,268 divided by 4 gets you 317.
All right, the last step in what we have to do is to draw a graph to graph our results. This is going to be a line graph. We'll draw 2 axes. This axis is the x-axis and this is the y-axis. And we'll label point 0 here. Along the x-axis, we'll have the stretch of the rubber band. in centimeters. We always want to remember to have our units. And along the y-axis will be the distance, or the average distance, that the rubber band traveled in centimeters. And then we'll create our intervals, and we'll start at 5 centimeters and we'll go down to 30 centimeters. And in our distance, we'll start at 100, and we'll do intervals of 50. So the average distance is along the y-axis, and we'll start plotting our points. Our first stretch was 10 centimeters, and it traveled an average of 250.5, so it's about right there, and we'll put a dot. At 15 centimeter stretch, our average distance traveled was 317. So we'll put a dot right about there. At 20 centimeters, our average distance was 387. We'll put our dot about there. And at 25 centimeters, our stretch was at about 430 off our graph. And then the last thing we will do is to connect our dots to determine if there is a relationship. So what is the relationship between the amount of stretch and the distance that it traveled? We would say that as the stretch of the band increased, the distance it traveled increased also. So there's a positive relationship between the distance that it traveled and the amount of stretch.